Dark matter is a known unknown, meaning it is something that is known to exist, but we just haven't found it yet. No one so far has detected a dark matter particle. Could it be like the planet Vulcan that it actually doesn't exist?
How much you would have to change our ideas about gravity to explain galaxies' behavior without dark matter. Researchers will keep looking into alternative explanations, but at least for now, no other idea is anywhere near as successful as dark matter is. So we'll just have to keep looking.
But that's no longer a simple explanation, and it's no longer predictive. So if it's not dark matter, then what else could it be? The alternative explanation to particle dark matter is modified gravity. The idea of modified gravity is that we are not missing a source for gravity, but that we have the law of gravity wrong.
Our contemporary mindset understandably considers the relationship between mass and gravity inviolate. That if you have X amount of mass, you have X amount of gravity. And from countless experiments, we know this is true so far as any combination of gas, liquids, and solids are concerned. But we do not know if this is true for plasma, the fourth state of matter. For this reason, I have devised a rudimentary sketch of a laboratory experiment that contests presently accepted electromagnetic gravitational dogma. A search through years of scientific journals and the web in general suggests that no attempt to date has been made to discern if gravitational induction is present at the moment of electrical discharge. I suspect there are two reasons for this. The first reason is due to the assumptions made of the behavior of electromagnetism by Hans Christian Ørsted in 1824, the basic tenets of which have not been revised or revisited in a contemporary setting. Ørsted and his successors simply did not have the tools sensitive enough to discern any weak interaction between the electromagnetic and gravity. The second reason is simply that it has not occurred to anyone to pursue this avenue because of the presumption of present electromagnetic dogma, which has been reinforced by almost 200 years of assumption. Fortunately, with the contemporary tools now available, it is possible to determine photon trajectory, and so this is fertile ground for laboratory experimentation. With the advent of a new generation of lasers that have the precision capacity of 1 × 10 to the -15 centimeters, and the now available highly sensitive interferometers, the experiment has more than a good chance of yielding a result that can determine one way or another if subspace exists. According to present theory, photons are not responsive to electromagnetic fields. Only gravity can alter the path of an unobstructed photon. Consequently, a laser beam of photons passing an electrical discharge and arriving at an interferometer is expected to denote no deviation caused by the discharge. This is an untested assumption. I propose that the interplay of electrons and protons in a magnetically organized plasma, such as one sees in lightning, produce momentary filaments of subspace. At the moment of their existence, these subspace filaments induce gravity without a corresponding quantity of mass. The rapid contraction and accompanying thunderclap at the collapse of a lightning discharge is, at its root, an induced gravitational event. So in our experiment, as the photons from the laser beam pass an artificially powerful induced electrical discharge, such as a Z-pinch, the photon path will be slightly diverted by the momentarily gravitational induction caused by subspace, and their arrival at the interferometer target will denote this. When one discounts the gravitational presence of the electron-proton mass that makes up the actual plasma discharge, there will be a further photon deviation that this mass cannot be accounted for, leaving little doubt that there is a gravitationally induced deviation of the photon. The experiment is repeatable and will confirm the observation.